All right, so this is in class example 4 for 343. You can see the beam that we have here, um, and some of the, one of my lines disappeared, some of the dimensions of the beam, and then the moment is 20 kilonewtons per meter, and you can see it, the direction that it's moving in. And we're supposed to find the maximum bending stress in the beam. So we'll just start off with the formula. So we know stress max equals MC over I. So we need to find, let's see, and we know that the neutral axis, because it's symmetrical, is going to be here. But so we need to know the M, which was given to us, 20 kilonewton meters. C, we know where the maximum would be. It would be the maximum compressive would be up at the very top, um, up here or here, and the maximum um, and tensile would be down at either of these. And the values would be the same for both of those because of the symmetrical design. So we need to find I is the main one we need to find. So let's see. And I guess I could have written C is going to equal the 100 millimeters because it's basically just the tip of that beam. So I equals 1/12 for a rectangle. It's 1/12 base times height to the height cubed. And we're basically dividing this into different pieces. I'm going to call this bottom part here as 1, and then these two sides as 2. Um, and so that is for the sort of part 1, and then plus, and then 2, because we have the two sides and they're the same, 1/12 base times height cubed of the second part, of the second pieces. And so that's going to equal, so we're looking at the 1 first. So 1/12, and the base would be 300 millimeters is all the way from here to here, so from edge to edge. And so that actual distance here is going to be that 300 minus 20, so minus this thickness, and then minus another 20. So, oh, that's something weird there. So 1/12, the base would be 300 millimeters minus 20 millimeters minus 20 millimeters. So that just gives us basically this length here for the base, and then times the height cubed. And the height is going to be that 20 millimeters, although it looks like I lost a piece of that. This is 20 here. So I have to make a little bit more room. So times that height cubed, which is 20 millimeters cubed. And so that's that first one. And so then we also need to do plus 2 times 1/12. And then the base of those side pieces are 20 millimeters. And then the height is 200 millimeters. And that one's cubed. So now we can just calculate that out. So it helps if I have my calculator. So the first bit of it is going to equal 173,333 plus, and then the second piece is 26,666, or 26,666.7. And so that's going to equal 26,840,000 millimeters to the fourth. So we have that now. We already have the C. So we have C, we have I, we have M was given, and now we can calculate it. So stress max, just that original equation that we had, equals M, which is 2,000 or sorry, 20, it was 20 kilonewtons. So it's 20,000 Newton meters times C, which is 100 millimeters. And then we need to get the meters to millimeters. So 1 meter is 1,000 millimeters. Cancel those out. And then divided by I, which is that 26,840,000 millimeters to the fourth. And so we have millimeters squared on the top. And so that'll take away two of them on the bottom. So we'll have newtons per millimeter squared, which will give us that megapascals. And we just calculate that out. And we get 74.5. Oh, check my settings again. 74.5 megapascals. And that's it.